Hey everybody, so in this lesson we're going to be beginning a new chapter, chapter 7. We're going to start off by talking about similar polygons. So polygons are similar if they have the same shape but different size. Now we've talked about congruent polygons. Congruent polygons have the same shape and same size, um, whereas similar polygons have the same shape but different size. So kind of like a car and a model car, a plane and a model plane, things like that. Same thing, like if you take a picture of something, that picture is similar to the actual object that you took a picture of. Okay, polygons are similar if the angles are congruent, and then the sides are proportional. So we talked about proportional in the past. So we're going to be setting up proportions in order to solve our problems here. The ratio of corresponding sides is called the scale factor. You might have heard this word before. And then if polygons are similar, then their perimeters are also proportional. Okay, so down in our first example, we'll talk about the scale factor. So the scale factor of triangle ABC to triangle DEF. So if we look at triangle ABC and triangle DEF, they are similar. They're not congruent because clearly triangle ABC is smaller than triangle DEF, but the sides are all proportional to each other. You can also tell if two triangles are similar based on their angle measures. So since all three of the angles are congruent to each other, that means that triangles are similar. So the scale factor is relating two corresponding sides to each other and then reducing that number. So you can pick any two sides that correspond to each other. Usually what I'll do, I'll just pick the smallest one. So in the triangle ABC, 8 is the smallest one. So I'm going to put 8 over, and then the smallest one in this would be 12. So the 8, which is the smallest in ABC, corresponds with the 12 in triangle DEF. And then we just reduce that fraction. The important thing here is ABC is the smaller one, DEF is the bigger one, so the small number has to go on top of the big number. So 8 over 12, they both reduce by dividing by 4, and that would reduce to 2 over 3. So that's called the scale factor. It's got a 2 to 3 ratio, those two shapes. Now the next one, what is the scale factor of DEF to ABC? All we're doing is we're just flipping the numbers. So instead of doing 8 over 12, we would do 12 over 8, which would reduce to 3 over 2. Okay, what is the ratio of the perimeters of DEF to ABC? So just like I set up in the top, if polygons are similar, then their perimeters are also proportional. So what we're going to do is we're going to do DEF first. So you want to add up all those sides. 12 plus 15 plus 27. And you get 54. So it'll be 54 over, and then 8 plus 10 plus 18 is 36. And then you want to divide that one. They both divide evenly by 18. And 18 goes into 54 3 times. 18 goes into 36 2 times, so that reduces to 3 over 2. Notice how they're the same scale factor when you just write the corresponding sides and then the corresponding perimeters, you get the same thing. All right, similarity statements. So first off, instead of writing the word is similar to, we're just going to use this little tilde symbol, like a little squiggle. That means is similar to. So a valid similarity statement must match corresponding angles and sides. Just like we've done with writing congruent statements in the past, similarity statements are the same thing. So what we want to do is we're going to match the corresponding angles together. So if I look at this first triangle here, I can name it in any way. How about I just name it ABC? So I'm going to write triangle ABC, and then is similar to, and this is where you have to match up the corresponding angles and sides. So A had one arc mark, D has one arc mark, so D goes first. B is the second letter, B has two arc marks, it matches with E, so E goes second. And then C is third, it has three arc marks, it matches with F, so F goes third. So triangle ABC is similar to triangle DEF. Okay, now down below we're going to write the list of congruent angles and proportional sides. So we're going to look at our similarity statement here. Based on this, this tells us everything. J corresponds with P. That means that angle J is congruent to angle P. K matches with M, so angle K is congruent to angle M. And then L matches with N, so angle L is congruent to angle N. Okay, so now we can write our congruent angles. So down below, we're just going to write what I just said. Angle J is congruent to angle P. Angle K is congruent to angle M. And then angle L is congruent to angle N. Now they want us to write a proportion relating the corresponding sides. So we're going to start off by just picking any side from one of the triangles. So I'm going to pick side JK. JK goes from one arc mark to two arc marks. So now I'm going to match it over here. One arc mark to two arc marks, that would be PM. I didn't really need the symbol there. Now I'm going to pick another side from this one. Since I started with JKL, I have to continue to use JKL and put that on the top. So another side would be KL, goes from two arc marks to three. And then two arc marks to three would be MN. And then our last one, I'll do JL. That goes from one arc mark to three arc marks. PN goes from 1 to 3. So that's our proportion matching the corresponding sides. All right, we're going to do the same thing with number 2. I'm going to do number 2 maybe without even putting the marks. I'm just going to look at the similarity statement. So I know X is congruent to R because they're both firsts. Angle Y is congruent to angle Y. And then angle Z is congruent to angle S. And then for the sides, XY corresponds with RY. YZ corresponds with YS. And then XZ corresponds with RS. So we can do it without even looking at the picture. Okay, now we're going to do some applications. So on the back, these pair of polygons are similar, give the scale factor of figure A to B. So the scale factor, again, is just writing a ratio comparing the two corresponding sides. So they want us to do A to B, so we're going to pick one of the sides in A and then match it up with the corresponding side in B. So we can pick either 3 or 4. I'll go with, how about 3? 3 is the smaller one. I'm going to match it with the smaller number on this side, which is 9. And that reduces to 1 over 3. So the scale factor of A to B is 1 to 3. Same thing for number 4. I'm going to pick the smallest one. That would be 8. And then the smallest one in the next picture would be 4. So the scale factor would be 8 over 4, which reduces to 2 over 1. So that's how we do scale factor. Just match up corresponding sides and then reduce the fraction. Okay, now we're going to actually use similar polygons to figure out missing side lengths. So in this question, they're telling us triangle ABC is similar to triangle DEF. So that means the corresponding sides are proportional. So what I'm going to do is I'm going to set up a proportion relating the corresponding sides. Usually when I do these, just my habit, I like to usually start with X. So I'm going to pick X first and put it over whatever side corresponds with X. So x is side DE. DE matches with AB, so I'm going to put 25 with x. And then the other number from triangle DEF was 28, so 28 goes on top. And that corresponds with, so that's EF. EF corresponds with BC, so that goes with 20. Now, when you solve a proportion, you just solve it by cross multiplying. Some of you might prefer reducing first. Some of you might just say, oh, I have a calculator. What's the point of wasting my time reducing? Either way is a valid reason. If I reduced 28 over 20, I guess I can divide everything by 4. So if I divide 28 by 4, and then I would get 7. And then I divided 20 by 4, I'll get 5. So this can reduce to 7 over 5. So that might seem easier. Otherwise, if I just cross multiply, if I do x times 20, I get 20x. And then 25 times 28. So this is just where the numbers get a little bit big. But if you're working with a calculator, it doesn't much matter. So you get 700. And then divide both sides by 20. And you get 35. Okay, now I'll just show you, if I was to instead go through with reducing, I would have gotten x over 25 equals 28 over 20. So let me reduce that. These both reduced by dividing by 4, so that would become x over 25 equals 7 over 5. Cross multiply, I get 5x equals 175. And then 175 divided by 5, I get x is 35. So notice I get the same answer because I didn't change the number. I didn't change 28 over 20. All I did was reduce it. I just made it look different. One other thing that I could have done. So at this point, what we could have also done is the two numbers on the bottom, they can reduce with each other. If I divide the bottom one by 5 and divide this one by 5, I would get x over 5 equals 7 over 1. Cross multiply, x times 1 is x. 7 times 5 is 35. Whoops. So either way, I would get the same answer. So you can apply the rules of reducing if you choose, but as you can see, we got the same answer all 3 times, whether we've reduced it or not. So going forward, just whatever you prefer. Maybe I'll just, for the rest of the questions, I won't reduce. But if you do reduce, just make sure you do get the same answer. Okay, so in number 6, we're just matching up the corresponding sides. So I'm going to start with one of these x values. So I'll just pick randomly x plus 6. That's side xd. Side xd corresponds with gm. So I'm going to put 36 with the x plus 6. Then I put equals and I do our other ratio, x plus 3. Again, if I put a side from the triangle on the right on the top for the first ratio, I have to do this side on the top for the second ratio. So x plus 5 or x plus 3 is xk, which corresponds with ga. So that's 32. All right, we're going to cross multiply. I would really I think it's a great idea if you just reduced these first. 32 and 36 can reduce with each other. Again, if you don't do that though, you're still going to get the same answer. So we're going to do 32 times x plus 6. I'm going to write that out. 32 times x plus 6. And notice how since it's a quantity, it's not just one number, it's a binomial here. I have to put it in parentheses. Equals, and then I'm going to do 36 multiplies with x plus 3. And then put the x plus 3 in parentheses because it's a binomial. Now, I have the parentheses, so I have to make sure I distribute. 32 distributes to the x into the 6, and then 36 distributes to the x into the 3. So when I multiply those together, 32 times x is 32x. 32 times 6 is 192. And 36 times x is 36x. And then 36 times 3 is 108. Okay, now we have our equation. We have variables on both sides. So I'm going to subtract 32x from both sides. And when I do that, I get 192 equals 4x plus 108. Now to solve this one, I subtract 192 minus 108, and I get 84. So we get 4x equals 84. And then I divide both sides by 4, and I get 21. So x is 21. Okay, number 7. So it looks like we have two triangles that are joined with each other. They give us the similarity statement. So again, just match up the corresponding sides. So they want us to find x and y, because the directions said solve for the missing measures. So I'm going to find, how about x first? So I'm going to start off by writing my x over. Now, x is side KL, it matches with ML, so I'd put it with 14. And now I'm going to pick another side. If I picked 45, 45 corresponds with y, so I would end up having two variables in my proportion, which wouldn't work. So I can't choose 45 in this one. I'm going to choose the 40. The 40 corresponds with the 16. Cross multiply, and then you get 16x equals 560. And then divide 560 divided by 16, and you get x is 35. All right, now to find y, we're going to do the same thing. Y, that's side ln. Ln corresponds with Lj, so Lj is 45. And then I write my other ratio. I have to pick, again, one, since I chose y, which was from the smaller triangle, I have to pick one from the smaller triangle. So now I can either do 16 over 40, or I can do 14 over 35, since we know x is now 35. I'm going to go with the 16 over 40, just because what if we accidentally got 35 wrong? What if that wasn't really the answer? Now I would end up getting a second wrong answer. So I'm going to stick with the numbers they gave us. 40 times y, that's 40y. And then 45 times 16, that's 720. And then 720 divided by 40, that gives us y is 18. All right, on to number 8. So number 8, we have two triangles there. One of them is just within the other triangle. So I wrote the word here, break up. What I'm going to do is I'm actually going to just redraw those as two separate triangles, just so you can see how this is going to work. So we have triangle ADE is the small one on the inside. And I'm just going to write all the sides that are there. So AD is 20, and then DE is 15. All right, the bigger triangle, that one's triangle ABC. All right, so now in this case, the big side, AB, it's not just 20 and it's not just 8, it's 20 plus 8, so it's 28. So that's the key thing here, is if you're talking about the whole side, you have to make sure you add the two parts together. And then BC is 2x plus 3. All right, so now we're going to set up a proportion. I'm going to start with my x value, 2x plus 3, corresponds with, so that's side BC. So BC corresponds with DE, which is 15. And then I'm going to do the other side from this triangle, 28, corresponds with AD, which is 20. All right, so to solve this proportion, cross multiply, 20 times 2x plus 3. I can write it out as 20 parentheses 2x plus 3. I'm just going to distribute right away. 20 multiplies with the 2x, and you get 40x. And then 20 also multiplies with the 3, and you get 60. And then we're going to do 28 times 15. 28 times 15. And you get 420. Solve this equation by subtracting 60, and you get 40x equals 360. and then divide that by 40, and you get 90, or 9. So x is 9. All right. All right, so I have a couple more practice problems that we're going to go over. So number 9, so we're going to do 3 more, and then we're going to have you do an assignment. So number 9, I'm going to try to do this one without breaking it into 2 separate pictures. But just remember what we're doing here is we're relating the 2 similar triangles with each other. So we have the small one inside of the bigger one. So one thing that you need to recognize in this is they're saying the entire length of ST is 40, and then the length of ZT is 5. We need to know what this length is. So if the whole thing's 40 and this piece is 5, we do 40 minus 5, and we get 35. So that's a number that we need to put there. Okay, now we're going to set up our proportion. So I'll start with the 2x plus 2. The 2x plus 2, that's yz. Yz corresponds with RT. So RT is the 3x minus 7. Okay, so I did the small side. So now I'm going to do the other small side, which is 35. 35 is SZ. SZ corresponds with ST, which is the entire length 40. All right, you're going to cross multiply. So like I said, you can write it out as 40 parentheses 2x plus 2, or I can just distribute right away. 40 times 2x, that's 80x. 40 times 2, that's going to be plus 80. 35 times 3, that's going to be 105x. And then 35 times 7, that's going to be minus 245. Okay, I have variables on both sides, so I'm going to do 105 minus 80, and I get 25x. And then I'm going to add 245 to both sides, and I get 325. So you can do that in multiple steps if you'd like. And then divide 325 divided by 25, and you get x is 13. Okay, so in the end, that's what you just want to make sure you have the right answer. If you do it a different way, if you take some extra steps to do it, just make sure you do get 13. Okay, the next one, I'm going to pick, we have these 2 triangles are similar to each other. So I'll start with DE, which is 6x plus 3. DE corresponds with GE, which is 17. And then I'm going to do the other part of DEC, which is 8x minus 1, which corresponds with 21. Cross multiply, and we're going to do 21 times 6. We get 126x plus, and then 3 times 21, that's going to be 63. And then we're going to multiply the 17 with the 8. You get 136x, and then 17 times negative 1 is minus 17. Subtract 126 from both sides, and you get 10x, and then add 17 to both sides, and you get 80. And then divide both sides by 10, and you get x is 8. All right, and then the last question. They're giving us all the side lengths of LKM. So if they give us all the side lengths, the perimeter is going to be 6 plus 5 plus 12, which is 23. Oh, 6 plus 15 plus 3. So that would be 33. So if the perimeter of the small one is 33, they want us to find the perimeter of the big one. If the scale factor is 3 to 5. So 3 to 5 is comparing the little one to the big. So there's the small numbers first, the big number second. So they would be comparing small to big. So we're going to set up a ratio. 3 over 5 equals, so that would be small triangle to big triangle equals, now we're going to do the small perimeter over the big perimeter, which we don't know, so I'm going to put an x. So that's how we would set that up. Cross multiply, 3 times x is 3x. 33 times 5 is 165, and then 165 divided by 3, and you get the perimeter, so x equals 55. So the perimeter of triangle PQR is 55. Okay, so that's all for this lesson. We'll give you some practice to try this out. Have a good day.